Today we're going to look at some word problems. Some of them are inequalities, some of them are equalities, and we're going to go through the exact same steps that we've been using. The fact that we're going to read one time, second time we're going to underline important information, circle what we're trying to find. What we're trying to find we will assign as the variable, and then we'll try to set up an equation or an inequality. So for number one, it says it costs $12 to attend a golf clinic with a local pro. Buckets of balls for the practice during the clinic cost $3 each. How many buckets can you buy at the clinic if you have $30 to spend? So let's go back and underline important information. If you want to pause the video and do that on your own, that would be great. Do it in pencil though. Right, so we're going to underline it costs $12. Buckets of balls, so we'll say, I'm just going to say buckets of golf balls during the clinic cost $3 each. So each bucket costs $3. So then how many buckets can you buy? That's what we want to know. How many buckets can you buy? And then this is information if you have $30 to spend. All right, so we've circled what we're trying to find. Buckets, so how about we assign that variable B? We want to know how many buckets of balls, so that's B. All right, so now we need to see if we can set up an equation. Well, we know we have $30 to spend, and so we know that the total cost of what we're going to do at the clinic has to equal $30, but it could be less than that. So I'm going to go back and make that less than or equal to 30, because if they spend less, that's okay. They just can't spend any more than 30. Can they spend 30? Yes. That's why we want to say it could equal 30 or be less than 30. If you need to pause to process that a minute, go ahead and do that. All right, so now total cost. Well, we have to add up everything that we're doing. And one thing we're doing is we have to pay $12 right off the bat. So we can say 12 plus, we're going to buy however many buckets of balls we buy, that number of buckets, they're $3 each. So we don't know how many buckets, so we're going to say we're going to spend $3 for each bucket, and so we'll have to multiply $3 times the number of buckets to get the total cost of all the buckets that and I put in, that's supposed to be a B, sorry. And then that has to be less than or equal to 30. So it's still, this is just our total cost. We've set up our inequality now. So now we want to solve for B. So we have to undo this. We're going to do the order of operations backwards and using the opposite operation so that we can get B alone. So let's draw our line. Here's our two sides. And the first thing we're going to do is we're going to take off this 12 to see if I take it off over here, then we'll be able to see how much money we can spend on our $3 buckets of balls. Okay, so you add last anyway. So we're going to do the opposite and subtract that cost. That way, we're done. We've got rid, or we've moved it sort of to the other side. And now we know that $3 buckets of balls, we have $18 to spend, because 30 minus $12, which is what we have to pay right up front, is equal to 18. So we bring down our less than or equal to symbol. So now we have $18 to spend on our $3 buckets of balls. So we're going to divide both sides by 3. And 3 divided by 3 is 1. That's good because remember we're trying to get B alone. So we have 1B is less than or equal to $6, which means not $6, 6 buckets. So B has to be less than or equal to 6 buckets. Okay, remember B is how many buckets of balls? 6, less than or equal to 6. Okay. So that's our solution. If we want to check and make sure, it could equal 6. So let's plug 6 back in, because if B is equal to 6, we should come out exactly right. So let's go 12 plus 3 times 6. Does that equal, is it less than or equal to, but it's going to be equal to 30, better be. So here we have 18. Add 18 to 12 by order of operations, we get 30. So that checks. Okay, now, if it's less than or equal to 6, that means anything less than 6, like 5. So if you want to just check 5, 5 times 3 is 15, plus 12 is 27, yep. So this would be less, we'd be spending $27 instead of 30, so we're good. All right, let's look at our next equation. If you need to pause and go back and review that one, please do. All right, so our next word problem says Paulo has $145 in his savings account. That was my little stand falling apart. He earns $36 a week for mowing lawns. If Paulo saves all of his earnings, after how many weeks will he have $433 saved? So let's go back and let's redo this again and underline it this time. So we're rereading. So Paulo has $145 in savings. He earns $36 a week mowing lawns. So $36 a week is important. If Paulo saves all of his earnings, so saves all of his earnings, after how many weeks will he have $433? After how many weeks will he have $433 saved? Okay, so after how many weeks? So we're going to assign our variable W. So that will be the number of weeks. All right, so now we know that he already has $145. He gets $36 for every week he works. So 1 week would be 36, 2 weeks 72, 3 weeks. So we want to see how many weeks we could go to until he saved exactly $433. So this would be an equation. And we know his total savings has to equal $433. Now, could it be greater? Absolutely. Okay, so we just want to know the first week that it goes over. So we can say it's an equation, but if you wanted to say greater than or equal to, you actually could. Okay, but we'll just go ahead and say equal to. So his total savings, well, let's add it all up. We know he already has $145, plus he's going to put in all his money for grass cutting, and he gets $36 a week. So we're going to say 36 times the number of weeks he works. That's got to equal 433. Could be greater than or equal to. We'll just leave it equal to. All right, so now we're going to solve. If you need to stop and go back and see how I set that up, you can stop and rewind. All right, so now, order of operations backwards. Well, we've got 145 added, and we multiply by 36. We multiply first, and then we add. So when we go in reverse order, we subtract 145. This is what he already has saved. So if I take that off of the $43, then I know he has $288 yet to earn. Okay, and here is $36 for each week. And this will tell me how many weeks he has to go to get the rest of that he has to earn. So now we want to solve for W, so we divide both sides by 36. And so we get 1W equals, and it comes out to be 8 weeks. Now, if you, let's see, if you divide that, 288 divided by 36, it's not going to come out exactly because, oh yeah, it is, because we got 8, it's 48, 4, and then 24 and 4 is 20. Yeah, it does come out evenly. So it's exactly 8 weeks. If it had come out a little more, then we want to say that it's going to take more than 8 weeks. So we're good. It's 8 weeks. So it did come out exact. All right. So now we're going to check that. So we're going to plug back in to check 145 plus 36 times 8. Does that equal, it's an 8 there. Does that equal 433? So let's see. 36 times 8, if you do that on your calculator, is 288 plus 145. If you do that, you're going to get back 433. So it does check. All right, one more. If you need to stop and pause and go back, be sure and do that. All right, last one. We've got Lori. She has $54. She wants to buy a sweater that costs $28 and 2 CDs. What is the most she can spend on each CD, assuming she buys 2 CDs at the same price? All right, so on this one, let's go back and say she, underline important information, she has $54 and she wants to buy a sweater, costs $28 and 2 CDs. Okay, what's the most? What is the most she can spend? Okay, so right there when we see the most, it can't be any more than that. That's what we're trying to find on each CD. Probably ought to circle that too. Assuming she buys 2 CDs at the same price. All right, so what's the most she can spend on the CDs? All right, well, the most she can spend on the CDs, we have to figure out what variable we want to use. So we could say C, okay, and we need to know that that is the amount she can spend on the CDs. Each. And that's important. Each one. Okay? So this is for one CD. All right, so now let's set up our inequality because it says the most she can spend. Okay, if she can't spend any more than the cost, then that means she cannot spend, or if she can't spend any more than $54, okay, she is going to, we're going to have to say that everything she buys, the total bought, or the total she buys, it has to be less than or equal to 54 because she can't spend any more than $55 or $54. That's all she has. So let's look at the total she buys. Well, she buys 2 CDs at this cost C, so we'll put that down. Plus, she also buys a sweater, and that costs $28, so let's put that down. And that total has to be less than or equal to 54. All right, so now, if you need to stop and pause and look at that, please do, because the wording's a little different here. You have to use some reasoning ability there to know. All right, so now we just need to solve this. So we're going to subtract 28 from both sides. Draw my line for the sides. And 54 minus 28 is 26. Bring down 28 divided by 20, or not divided, minus 28 is 0. And 2c plus 0 is just my 2c. And then I'm going to divide both sides by 2. And when I do that, I get 1c, or c alone, is less than or equal to 13. Okay, so remember, C was the amount she spent on each CD, so she can spend less than or equal to $13 on each CD. So she don't want to spend, she don't want to buy any more than $13 CDs. All right, and if you check that, you can go back and say 2 times 13 plus 28. Is that less than or equal to 54? It should be equal this time. So